Hello and welcome again to this YouTube channel. Now we can move further to another different function. Okay, in this case we have a special function. I put them together because they are very close friend, the exponent and also the logarithm function. Okay, what's interesting about this function, all right, it's the special part of solving your differentiation. Okay, so if let's say you have ex in the case, if let's say you have ex, so if you differentiate your ex, you will get, originally you will get as is. Okay, you will get also ex. Okay, so I put it over here. Okay, this one is at the, okay, this part. So it does not disturb any other things. If let's say you have this, okay, the special part is if let's say you need to find dy dx, you get exactly as it is. Okay, and the special part of your ln, that's why ln and exponent is very special. Okay, if let's say you have ln x, the special part, if you put dy dx over here, you will get 1 over x. Okay, it looks quite you may have, you may get confused why that is so. Okay, always as I remember, as I mentioned earlier, if you are very interested to look at why that is so, you need to go back to your first principle of differentiation, and then you need to start back with your fs plus h, and then you can see, oh, actually that's why you finally get your dy dx. Okay, as I mentioned earlier, your rules is just for you to improvise thing a little bit, shortcut your way out of your solution for your prime. Okay, now in this case, whatever happen if let's say my value, my function, my exponent function now not just straightforward ex, okay, but my power now is in the form of another function. All right, so what you need to do, okay, it's quite similar to how you have the power function. Okay, so you start with first making sure that you put the same exponent, put the same value together. Okay, but okay, I put in a bracket form so that it's easier for you to get, to not to not get confused. And then your next bracket is actually for a category where you prime. Okay, where you prime or where you make the differentiation for your power function. Okay, in this case your power function is 2x plus 1, and then once you differentiate your 2x plus 1, you will get 2. That is the idea behind that. Okay, so you finally you simplify that form. This is what you get. Okay, interesting, isn't it? So if you still get confused with that, okay, you imagine your y is actually e, and then your power, your e now is actually in this form f, okay, which is a function, another function, and then how you find your dy dx, you put it as it is, the same thing as you, how you what you have this, but now since your value at the top now is f instead of only x, then you need to multiply. I put the dot function, dot multiplication, and then you multiply with the prime for your x. Okay, that's the reasons behind why you have 2 in your solution. All right, so the same thing happens for your logarithm function. Okay, once you need to find dy dx, okay, as how as what you have for your exponent, you put the value together, but in this case your ln now refer to my right hand side. Okay, at the uh, uh, box of my right hand side. Okay, over here, Okay, you refer to this one. Once you have y, you will have once you have y equals to ln x, your dy dx now becomes 1 over x. So the same thing happens over here, but in this case, your ln now is not just x. Your ln now is in the form of fx. Okay, fx in this case is a cube function, a cubic function. So what you have now is you put 1 over, okay, and then over, this over now becomes fx. Your fx now is a cubic function. Okay, you put all your value in your cubic function, put them together. If let's say you have other than x cube, you have, let's say, x cube plus 2x plus whatever, you put all those values inside the bracket of your ln to be your denominator. Okay, so this one is not finished yet. I put that also in a bracket so that not to confuse you. And then you need to find the valuation of your derivative for your particular function inside your ln. Okay, in this case your s cube. Okay, so you differentiate your x cubic function, so you will have 3x square. All right. So once you have this, you can see, oh, my denominator and numerator is a little bit, you can cancel things. So now once you cancel them together, this is what you have. Okay, so uh, many people are quite afraid when they find exponent and also logarithm in their problem. But if you look back at your valuation, exponent and logarithm is actually one of the straightforward solutions. Okay, it's just that most people didn't get the value of it because they see exponent and logarithm as an alien. Okay, because they are not comfortable and not familiar with and also ln. All right, that's why most of it is just psychological, not because of your algebra knowledge. Okay, so if you are able to reduce a little bit your anxiety on exponent and logarithm, which I hope you do, then you will see that it will help you a lot, especially in solving this type of particular problems. Okay, so I hope you enjoy this video. I'll see you guys on the next lesson. All the best.